We'll do a couple of practice problems here to go over combination circuits. So here's the first one. Notice that each item here has a voltage, a current, and a resistance, okay? In this case, our source does not give us our voltage. We actually have the amperage given to us, so we're going to have to solve for the voltage, okay? And so we're going to start with rule 1 on this, okay? Because what we need to do first is we need to get the total resistance. So rule 1 says look for items in series. And we do have, this is in series and this is in series. So we can do these two series. So I'm going to start by redrawing this right here. And I'm going to take these two and I'm going to put them in series like this. And I'm going to take these two and I put them in series and I reduced them to 1, okay? So over here, I don't have the voltage. All I had over here was I total of 1 amp, okay? But this resistor was 325, and this resistor was 275. So we know that the R total there is 325 plus 275 ohms. Well, 325 plus 275 is 600 ohms. So the reduction of these two series yields 600 ohms right there, okay? The next one, these two became reduced into the single because they were in series. And we had our total there of 150 ohms. That's what that is. And this is 250 ohms. Okay? 150 plus 250 is 400 ohms. So this right here becomes 400 ohms. So our circuit is getting simpler, but it's not all the way simplified yet. So we go back to our rule 1. We don't have anything in series, but rule 2 says we have at least two things in parallel. So these two right here can get further reduced. So if I draw this circuit again, all I know is I total is 1 amp over here, but I'm going to reduce this and do a single one circuit, and we know in order to get that, we have 1 over our total is equal to 1 over 600 ohms plus 1 over 400 ohms, okay? So if I go ahead and divide that out, I'm going to get 1 divided by 600 plus 1 divided by 400 equals. But remember, I have the reciprocal, so I need to flip that answer. I need to take the 1 over x here on it, and I get 240 ohms. So right here, I have 240 ohms, okay? So now I can start trying to figure out what I've got going here. I have current and I have resistance. But so that means I've got 2, I could get voltage here. So we know that voltage is current times resistance. So in this case, voltage is going to be 1 amp times 240 ohms equals 240 volts. So this is voltage 240 volts. And if I put 240 volts up against a 240 ohm load, I would get 1 amp to flow in the circuit, okay? So now we're gonna back it up. So we're gonna take what we know from here. We know the voltage, we know the current, and we know the resistance, and we're gonna back it up to this circuit, okay? So our circuit, when we move backwards, is either gonna be a series circuit in which current stays the same, or it's gonna be a parallel circuit in which voltage stays the same, okay? So if I look at this one, this is a parallel circuit. So I know that voltage stays the same. So if I come and I look at this resistor right here, we said that this resistor had 240 volts on it. So if I back it up to here, I know that 240 volts stays the same on each one of those. So now I can calculate the current here. And so my current here is going to be I is V over R. And so I've got 240 volts over 600 ohms. Okay, that's going to be my first one here. And then my second one here is going to be V over R, 240 volts over 400 ohms. Okay, so if I run those numbers, 240 divided by 600 gives me 0.4 amps. So this one has 0.4 amps on it. And if I do 240 divided by 400, I got 0.6 amps. So this one right here is 0.6 amps. So this was 0.4 amps, this was 0.6 amps. And just to check a little bit, remember that in a parallel, the current divides, but we can't lose current and we can't create current. So therefore, this division must equal up to what our source is. And sure enough, 0.4 and 0.6 is equal to 1 amp. So we're looking pretty good right here, okay? And also we know right here that we've already got the voltage here. There's 240 volts dropping across here. So our voltage source over here is 240 volts. So we're doing well here, okay? Now we're just going to back up again. And if we take a look at this item here, we know that this is a series circuit, and this was the reduction into a single one. So when we back up, we know that in series, current stays the same. In parallel, voltage stays the same. This is series, current stays the same. So we know that the current on this one is 0.4 amps. So this becomes 0.4 amps, and this one right here becomes 0.4 amps, okay, on that one. Here, this is the reduction of here. So this is 0.6 amps. So we know the current on this one stays the same, 0.6 amps. And the current on this one stays the same, 0.6 amps. Okay? Finally, we need the voltage here, the voltage here, the voltage here, and the voltage here. And so what is voltage? Voltage equals current times resistance. All right? So here I have the current of 0.4 and the resistance of 325. So here we go. 0.4 times 325 equals 130 volts. So this one is 130 volts. Let's do the next one. 0.4 amps times resistance, 275. I get 110 volts on this one. 110 volts, okay? Well, let's see if that makes sense. From here to here, this one drops 130, and this one drops another 110. Well, we said that we had 240 volts here. This is just coming up. So 130 plus 110, 130 plus 110 is 240. So this is dropping. Let's do it here. We have current times resistance. 0.6 times 150 equals 90 volts. Now remember, this 90 and this voltage here have to equal 240. I bet this comes out to be 150 volts here, just to be sure that it's 240. Let's check. I got 0.6 amps times 250 ohms. I got 150 volts. 150 volts, sure enough, 150 plus 90 is 240 volts because the voltage drop from the top to the bottom here is 240 volts. Doesn't matter if it runs through one resistor or two resistors in series, because this is a parallel circuit and it drops from 240 volts to 0. So that's the way that you work through that one there.